In this demo, we're going to talk about what happens when you combine Cribble LogStream with the Elastic stack. We're going to talk about real world examples of customers who are using this great combination to do routing, replay, migration, reduction, enrichment, and many more use cases. However, before we start, let's talk about Cribble LogStream. Cribble LogStream sits in between inputs like syslog, Elastic Beats, Fluentd, Kafka, and destinations like um, syslogs, Elastic, and many more. In the middle, Cribble takes that data, the observability data, which is logs, metrics, traces, and enabling us to do routing, data reduction, data transformations, as well as it allows us to go in and send that stream of data to a cheap object store and then replay that data for a later investigation. The first use case I'm going to cover is routing, and this is Cribble's LogStream ability to reuse your existing data sources and agents to route your observability data to Elastic Stack. Looking at LogStream's architecture, we see that on the left side, LogStream can take any of these data sources, these inputs, and the value here from an Elastic search point of view is the ability to take data that comes from Kafka, Fluentd, Syslog, of course, Elastic Beats itself, or even Splunk UF, ingest that data. When we ingest the data into Cribble LogStream, we ingest the data into this, from an architecture point of view, a concept we call a worker node. A worker node is a stateless node that allows Cribble to receive the data, process it, and send that data to Elastic as a destination. The worker node, whether or not you have 1 terabyte of data being ingested daily, or you have 1 petabyte data being ingested daily, it can scale horizontally. And so the more of these worker nodes, the more volume you can process through the system. And from a routing use case point of view, it is the use case that we see many of our Elastic customers using Cribble LogStream. The entire configuration is done through the leader node. Looking at LogStream, the UI, we see that to achieve that use case of routing, we can use LogStream to monitor this entire traffic, but we can also see, in addition to monitoring the traffic, this visualization that allows us to see the data flow from the multiple data sources to Elastic. And diving into the configuration, we can see the Cribble LogStream UI where we can configure this use case by adding syslog data to Cribble, of course, Elastic Beats, Kafka, and multiple sources to Cribble. And once we add these multiple data sources to Cribble, we can then go into the destinations and point Cribble to your Elastic Search instance. And by doing that, it allows Cribble to route multiple data sources into your Elastic instance. For example, in my instance here, I have 2 Elastic destinations. One of them is my local ElasticSearch instance, and the other one is an Elastic Cloud. And what Cribble allows us to do is to receive the data from the multiple data sources that we mentioned earlier, manipulate the data, and then send the data to Elastic. And once the data lands in Elastic, as we can see here from my instance of Kibana, we can then go in and do the searches and the analytics on the Elastic side with the data that was manipulated from a syslog or from Kafka into the Elastic stack. And this first use case is a very popular usage for the many customers that are using both Elastic and Cribble as a combination. The next use case that we see many Elastic customers use Cribble for is called replay. It's the ability to achieve big saving by retaining the observability data in a lower cost object store and then replay that data once you need to do some sort of a security investigation based on this historical data. To see this use case in action, let's select Cribble routing and data routes and expand this route right here called archival. What this routes allows us to see is that we have in Cribble the ability to send the entire payload from syslog, from Elastic Beats, from Kafka, or from any of the multiple data sources that Cribble supports into a cheap object store without truly touching it. This use case allows us to see that while subset of a data may go to Elastic, we can send the entire payload into this archival store. In this particular case, I'm sending everything to AWS S3. And then once we need this data, once we want to have an investigation from this historical data that we archived, we can then go in to Cribble, click on the collectors. The collectors are then can run or be scheduled to retrieve that data from AWS or from Azure Blob Store or from Google. And once the data has been retrieved, this historical data can then be sent for investigation from this cheap object store to Elastic to do the security investigation. For example, we have a customer that is currently in production that's using to send about 50% of the data that they retrieve from about 20 different sources. So 50% of that data is going to Elastic, but 100% of the data is going to Wasabi. Wasabi is a version of S3. And then once they need that data, they go in, push this replay capability, and then retrieve this historical data whenever that security investigation actually happened back into Elastic for further investigation. The third use case that we see customers using Elastic and Cribble LogStream combination is around migration. This use case make it easier to migrate your data from an older version to a newer version of Elastic. To achieve this use case, let's go back to LogStream UI, click on data sources. For this particular use case, the customer has chose to use the Cribble REST collectors, and we can see that by simply using the Elastic API, the REST API, we can create some sort of a search that goes against the Elastic indexes and then run this search to retrieve the data from that older version of Elastic and then we can route the result data to the newer version of Elastic. The fourth use case that we see Elastic customers using Cribble for is around data reduction. And this one has multiple versions of that. For example, we have a few customers that are using the Cribble reduction to eliminate data that has no analytic value. For example, they contain nulls or the strings are empty. And so this kind of use case is very popular. As I mentioned earlier, for example, I have a customer that has several terabytes coming into Cribble every single day. However, only 50% of that data is going to Elastic, and they are achieving it by using Cribble data reduction. Let's take a look at how to do data reduction using Cribble Elastic Collector pipeline. However, before we do that, there's one really nice feature that many of our customers love to see, and that is the ability of Cribble to capture live data. And once we capture this live data, Cribble can then save this data as a sample file. And once Cribble save it as a sample file, the customer can then go in, click on the pipeline, and compare the pipeline that they have built against that live data that they captured. And so, for example, in this case, I have the data reduction, but before we do data reduction, we're going to go through and build a pipeline that we are going to send to Elastic. So the very first thing we can see that in this example, the customer captured data that is actually key value pair. The very first thing we ask Cribble is to parse the data. However, from a data reduction point of view, and we can see it right here on the bottom, we asked Cribble to remove any field that is empty. And so that's the very first thing we did at this particular pipeline. The next thing, for this particular customer, we can see that there are values, PII values, that are in the clear. So Cribble's ability to go in and mask data has been proven as a very nice feature to turn this data from a PII in the clear to a masked data. After that, the next part that we did for this particular customer is we turned the data from a key value pair into a JSON object, which is much friendlier from an Elastic point of view. Next, we are going to show how the customer removed duplicate events. In this case, we used the sampling function. The sampling function allows us to look at the events, and if there are fields that match a certain criteria, in this case, let's assume the phone type is iPhone, just like the one that we see in this particular event, we can ask Cribble to keep one out of X number of events. So once we save this function, Cribble then removes these events from the payload. And once we click on the basic statistics, we can see how many events Cribble decide to keep before sending the data to Elastic. So that is the sampling. The last function that we have in this pipeline is the eval function. And in this particular case, what we have done for this customer is we assigned a different date
for the index before we sending it to Elastic. And the reason we have done that is so that Elastic can store the data at a different index based on the day. Every single day it will be a different index. Also, we can see in this eval that Cribble can keep some of these fields and remove some of the fields, so that by us adding those fields to the payload, we can see that the final outcome can look something along the lines of these events. And also, if we again looking at the basic statistics, we can see that Cribble, give or take, reduced 70 plus percent of the payload before sending the data to Elastic.
In addition to the parser and the sampling that we just demonstrated, Cribble comes with a large array of additional functions that you can use with different use cases. For example, the suppress, very similar to deduplication of the data based on time, or the drop, which is very popular once you want to drop events altogether. This is a really strong, powerful feature whenever you want to remove, for example, if you have lots of firewall data or network data that you do not need, you can use the drop function to remove those events altogether. The fifth use case that we see Elastic customers using Cribble with is around enrichment. Enrichment really means the ability to take lookup tables, for example, DNS lookup, GeoIP lookup, or even the Redis in-memory database, to enrich the events for a better security investigation. Looking at an example pipeline that does enrichment and expanding the pipeline, we can see Cribble's ability to do the GeoIP enrichment in the pipeline before we send the data to Elastic allows us to do the following. First of all, it's allowing us to improve ElasticSearch performance by offloading this processing to the pipeline before we send the data to Elastic. Elastic does not have to do any lookup during the search time, as well as if, for example, the person does the search in Elastic a month from now, they know that this information was true at the time of ingestion. That means that performance can be improved, as well as the accuracy of the data can be measured based on the time of ingestion, which means that lookup is a very popular use case that we see all the time people using Cribble with and ElasticSearch. And the last use cases that we see many customers using Cribble and Elastic combination is around masking, which I showed in the demo, logs to metrics, the ability to transform log data to metrics data before we send it to Elastic, Elastic templating, ability to create those templates in Cribble, LogStream, and then finally, that I showed earlier in the demo, is the ability to manipulate the index name on the fly, the Elastic index name on the fly. So with that, I hope you learned on some of the use cases that you can use your Elastic Stack with Cribble LogStream. The use cases that we highlighted are routing from multiple data sources to potentially multiple Elastic destinations, the whole notion of replaying the data for a better security investigation, the ability to migrate your older Elastic stack to a newer version, the ability to do data reduction before we send the data to Elastic, and that has multiple versions of that. And finally, the ability to do enrichment, and that is the notion of lookups and alike to enrich the data on the fly before we send the data to Elastic. Thank you.